standard, we must use a linear or first order calibration. Press the start key. Aspirating our blank, press the enter key. Once the 0 is set, we go into our standard. Again, wait a few seconds for the solution to equilibrate in the burner. Press the enter key again to take the first reading, then the second reading, the average being displayed in your calibration table. Press the calibrate key, the yes key, and the enter key to see the 1-point calibration curve. At this point, we can press escape, go back to our active analysis screen, and read our samples or recalibrate on our standards as needed. Again, the read key is used to read the samples, the auto 0 key is used to auto 0 the blank, and the reslope key is used to reslope the high standard. Again, please refer to the Buck Scientific Complete Operator's Manual or the mini guide for specific details on this operation. From nitrous oxide shutdown, you want to remove the Teflon line from the sample cup. Let it run dry for a few seconds. Then press the air key to switch back to air acetylene. Again, going to the very rich flame and then shrinking down to our normal flame. We can bring our fuel flow to our next level depending upon what element we're going to run, and then either continue to run that element or press the off key. This concludes the basic. To ensure many years of satisfactory service on your Buck 211 AA system, there are several basic maintenance steps that the operator can do periodically to ensure long life and good performance from his instrumentation. If you are running high solid samples, there's a possibility of salt buildup or crystal deposits inside of the nebulizer. These can be cleaned with a spring steel wire included in your installation kit. Likewise, in an air acetylene or nitrous oxide acetylene burner head, high solids can cause the buildup of salts there as well, causing clogs or inconsistent results. And for nitrous oxide operations specifically, there's a potential buildup of carbon due to the very rich flame conditions, and these can be knocked off using one of the high temperature steel wrenches included in the installation kit. As previously mentioned, with a nitrous oxide flame, you will get a buildup of carbon at the top of the burner slot. Using one of the high temperature wrenches, while the flame is lit, just scrape it along and knock off the carbon as shown here. In addition to the installation tools, you'll have a burner slot cleaning tool as part of your installation kit, and also a bag with several spring steel wires used to clean the nebulizer, as previously mentioned. To knock out any potential clogs in the nebulizer, remove the Teflon sample line and put aside. Then carefully thread the steel wire into the end of the nebulizer needle and move it back and forth to dislodge any of the potential clog material. This is a good standard practice if you are running high dissolved solids or high salt materials. Carefully replace the Teflon line without kinking it, and you will get consistent flow of samples. If you find a clog in the burner head, as shown by an uneven flame, use the slot cleaning tool and insert it into the opening of the burner head and move it back and forth. Sometimes it is a good idea to do this periodically, and on an annual basis or semi-annual basis, actually remove the burner head and rinse it with some dilute acid to remove any solidly built up deposits on the inside. The burner heads are made of titanium and can be cleaned with nitric acid or dilute hydrochloric acid. To maximize the performance of your Buck 211AA, there are a number of optimizations that can be performed to get the maximum absorbance energy from your standards and samples. Following the procedures detailed in the manual and the mini guide, you can optimize the nebulizer by aspirating a standard and adjusting the black ring of the nebulizer clockwise or anti-clockwise to achieve the maximum absorbance signal. After this is done, the burner position can be adjusted both horizontally and vertically, again to achieve the maximum absorbance signal from a standard. For nitrous oxide, these steps are critical along with the fuel adjustment, and it is very important to utilize some ionization buffer, either potassium or lithium, to compensate for ionization effects in the very hot flame of nitrous oxide acetylene. Due to the instabilities inherent with nitrous oxide operation, it is recommended to recheck the standards often, usually after every 5 sample readings. It is important to observe proper chemistry protocols when preparing your samples and standards as well. Deionized water alone should never be used for dilutions, as certain metals will hydrolyze or precipitate in short time. Using 1 to 2% acid, either hydrochloric acid or nitric acid, depending upon your metals, will maintain a good blank and standard stability. At the end of an analysis, it is strongly recommended to run 100 or 200 milliliters of your dilute acid blank to rinse out the spray chamber and the burner head after any dirty samples containing particulates, organics, or high solids content. To avoid damage to the flow meters of the 211AA, it is recommended that you replace the acetylene tank when the primary tank pressure drops to approximately 100 pounds per square inch. For good optical stability, you should maintain the instrument in a laboratory environment that has a fairly constant temperature. This concludes our installation and basic operations training videotape of the Buck Scientific Model 211 AAS instrument. Please refer to the complete manual and also the enclosed mini guide for the Model 211 for details on any of the steps shown in this video. You may call us toll-free at our 800 number for technical support, or email us at support@bucksci.com for more help. Thank you.